Hello everybody, welcome back to another SpaceEngine Exploration video. It's been a while, like a pretty long while since the last one, and I've gotten lots of requests to keep going and making them. So we're gonna be flying around SpaceEngine and seeing what kind of stuff we can find. If you guys would like to see more of this series, let me know in the comments and leave a like on the video, and I'll keep making them because you guys seem to really like them. Right now, we are here at planet Jupiter, the biggest planet in the solar system, and I think we could start here today. The way that SpaceEngine can show some of our planets in our solar system is just crazy. Like the detail, even though it's not the same as the generated planets, it's still insane, and especially looking at some of its moons too. So here's Jupiter in a realistic lighting. So this is honestly very, very, very similar to what it would look like to be here actually and see it with your own eyes. And you can see, I think this is this Io? That is Europa, yeah. And look, you can even see, if you let the light adjust, you can see Jupiter's rings. You can see it has a pretty big ring system. They're just so dim in comparison to like Saturn's rings. And as soon as the camera changes exposure, it completely disappears. But Jupiter does have a very, very big ring system similar to Saturn in size. Look, check this out. Turn up the exposure a lot. There we go. And you can see, wow. They're shadowed here. It looks like it disappears, but that's actually just the shadow. Let's see if I go on the back side, you can start to see it. There you go. So you can see Jupiter there with its rings. If they were as bright as Saturn's, it would look very similar to Saturn, which is very, very cool to see. I think this one is Io over here. So Io has tons of volcanoes on it. And wow, just look at that. So realistic lighting, this is more what you are going to see in real life. But let's go down to the surface of Io as our first object to look at today, because look at some of these mountain ranges. We could get closer and even see the detail of the ground. Wow. And look around. So if you don't know, you can see Jupiter there. SpaceEngine does a really good job of simulating randomly generated planets. It's not as good at showing planets and moons in our solar system just because the game doesn't want to lie to you. It doesn't want to show you something that's not there. But if the game can create its own planets, it can come up with whatever, you know? So let's see if we can maybe wait for like a eclipse type thing here. Wait for the sun to be covering. Oh, wow. Okay, this is actually really cool. So we're on the surface of Io right now. And this is realistic lighting, so the ground is going to be lit by Jupiter, but look how bright Jupiter is. Once the camera adjusts, you can't see the ground at all. And just check that out. So real time, you might actually be able to see the movement, because Jupiter spins very quickly. I bet if we zoom in enough, you can maybe start to see some of the... Oh, maybe not. How fast do we need to go? That's 3 times, 10 times... Okay, at 100 times speed, you can start to see the movement. Just the swirling of these storms is so cool to me. Insanely detailed. Wow. Wow. Okay, let's take a look at some of Jupiter's other moons. So SpaceEngine only will show these 4 in the planet browser, but I think if we go here, it might show more. I'm actually not sure. Oh no, it looks like SpaceEngine. Oh no, it does. Look, it does. It does. So even though Jupiter has so many moons, we're only going to see these 4 of the main ones, but it does have all of Jupiter's smaller moons. These are more like asteroids, and they're further out, it looks like. Let's go land on this and see. Let me search Jupiter so it's focused. Okay, so this is still one of Jupiter's moons, but look how much further away it is than like Io that we were just on. You got to zoom in so far to even see it. But Jupiter's gravity, the pull on these moons is so strong that it can keep these in orbit even though they're so far away. Kind of cool. It's got a very, very large sphere of influence, but I wanted to see some of its more famous moons. Let's go to Europa. Okay, here is Europa. Very, very cool. This one's got like weird scratching patterns. I'm not quite sure what makes these. If you know, let me know in the comments if you know what causes this kind of scratchy look to the surface. Because some of Space Engine's randomly generated objects will have some similar kind of features. Wow, okay, realistic lighting, we're looking more like this. And you can see where there's higher quality images. You can see the difference. So it looks like there's higher quality. We know more detail around this strip. There maybe was, I don't know which, there's probably a satellite taking pictures or something. Because like stuff like this, we can start to see a lot of detail, but around here, we don't know as much. But there's some random spots with higher detail. Different spots are going to have more. Like down here looks pretty good. Oh, look, like right there, there's a lot of detail. But that's why I almost like going to procedurally generated stuff by the game, because the game will give you the highest quality possible. Okay, let's just zoom in here. What is this one? This is Ganymede. So this is the largest moon. I'm pretty sure Ganymede's the biggest in the whole solar system. I think it's bigger than our moon even, or bigger than Mercury. I mean, obviously it's bigger than our moon if it's the biggest moon. What is happening? Go to Ganymede, please. Get a little closer. Okay, so here's Ganymede. Very, very cool looking moon. Like, check that out. And similar thing here with the detail. You can see where there's definitely spots where we have higher quality images, and then spots with lower quality. Up here, it looks like we don't know as much. Let's go land in one of the higher detailed spots, like this crater here. Looks a little higher detailed. The detail already, like no matter what object you go on in the solar system, it completely falls apart once you get to the surface. But wow, okay, so here's the surface of Ganymede. It would probably not look this smooth if you were really here. It'd be rockier. And there is Jupiter, and you do have a view of a couple other moons, and you can actually see them moving. Check that out. What is that? That's one of its moons too. Yeah, Amalthea, Jupiter 5. So that's its 5th moon in its orbit. Interesting. And then there it is once again, Jupiter. Okay, let's take a final look at Callisto, the last one of its 4 main moons. Very cool. I think Callisto might be my favorite. I love the way it looks. The heavily cratered surface is really cool. It looks kind of similar to Mercury, but like more colorful. And all the craters have like white spots, which is kind of cool too. I want to see what the other side looks like in the light. So let's speed up time and wait for it to kind of rotate around. So there's a full view of Callisto rotating around. Very cool. Obviously, Space Engine looks really good. Like, it's got to be the best way to experience the solar system without actually, you know, flying out into space. Wow. Okay, and it's got like almost like deserty kind of cracks in the surface. Very, very smooth. I don't know how smooth it really would be. There's Jupiter again. You can see the view of its moons are kind of crazy. Okay, so that is Jupiter, but let's go ahead and get out of the solar system, because everyone knows the solar system. Let's see what we can find out here. Let's just look at a few of the stars that are nearby. Let's take a look at this planet. This kind of looks cool, and we'll go to this green one too. So like what I was saying, watch the detail. As I zoom in, it doesn't lose detail. It generates more and more detail, till you can actually see the physical rocks on that mountain range there. This is why I love Space Engine. It is so insane to be able to go to exoplanets and see stuff like this. Obviously, it's not real, but it is realistic. Like, these could totally exist. And like, you see a crater, you can go actually in the crater. Like, we're inside of that crater now. And we got the blue atmosphere. This is cool. Being able to see these entire mountain range type things is really cool too. Let's watch a sunset, because I'm interested to see what a sunset would look like on this blue skied planet. It's not blue like Earth, it's blue like like a lighter blue cyan color. Okay, let's play time and watch a sunset here. We can see there's Aurora Borealis, so there's a lot of radiation coming off the star, it looks like. Is it tidally locked? No. It's setting. Okay. Ooh, okay. There's a sunset. You can see more Northern Lights type stuff. As it sets, it almost has like a pink hue. And then we are left with crazy amounts of Aurora Borealis. That's interesting. I don't know if I've ever seen this much on a planet. Are we towards the pole? That would definitely help with that. I actually don't know if we are. Yeah, we're right on the North Pole. That's why there was so much. Because the magnetic field targets them towards the poles. And wow, we're not that far away from our system, so I want to see if any of the constellations are the same. I don't recognize anything. That looks like the Orion Nebula, which it is, but that's not the same shape of Orion. So it's interesting how just a planet a few solar systems away, the constellations are completely different because you're looking at the stars from a new angle. Like, I think this is Orion's belt right here. But it does not look the same. Like, that would not be Orion. And then there's the Pleiades, which looks pretty similar, but a little bit different. It's a little bit warped. It's kind of weird to see constellations that we all know in a different way. Interesting. Okay. Let's go to that green planet that was also in this system. This is a Terra. Is that a green atmosphere? I think so. Looks like there's not any, like, water on the surface. Okay, let's go down here into this. Oh, that looks like liquid water, actually. Yeah, there's a little canyon here. Just a baby canyon. Very green. This is a super thick green atmosphere. What's our temperature? Oh, yeah, here we go. Local temperature right here. It says 65 Celsius. So it's warm, but it's not... like, yeah, you wouldn't be able to live in that, but... it's not, like, extremely hot. So I think it's almost got... it's kind of similar to Venus, I think. It's got 7 moons, though? What? Let's go look at some of its moons. Okay, so here is its closest moon, and you can see the planet there in the background. The green atmosphere, during sunset, it turns purple. Check that out. We can even see it from orbit. Purple atmosphere. Green atmosphere turning purple. Very cool. Let's see the biggest moon. This is the biggest one by far. It's the only one that is even circular. The rest of them are just tiny little asteroids. And even this is not very big at all. Nothing really substantial in terms of moons. But here is its biggest moon. You can see the Milky Way there. And there is the planet. That's the Carina Nebula, right? Yeah. Interesting. Okay. Oh, what's that there? Is that another planet in this system? Yeah, it is. Check that out. Wait, it has an atmosphere? Wait, let's go over to that. Oh, I need to zoom out and then go to it. Okay, so this looks almost like a moon, but it's got an atmosphere. You can see that blue hue going around it. Let's go closer. It's got some volcanic activity. Oh, wow. This is cool. This almost looks like the moon, like our moon, but there's a blue sky. A very faint blue sky. Our pressure is... oh, wow. Check that out. It's 0.0005 atmospheres, which is very, very, very small. Just barely enough to even be visible, I think. It's got some pretty cool features, though. This looks very similar to the moon. The moon might be a little more gray. This kind of has some browns in it, tan colors. And this planet has 4 moons. What's our size here? Half the diameter of Earth. So it's actually fairly large. And all of these moons are just similar asteroid type things. This kind of stuff. That's cool. I like the way this planet looks a lot. Wow. Okay. Let's go to a new system. Let's zoom out here. Okay. This is a bright star. Let's see what's around this. So binary system with actually no planets. These are all known stars because we're still really close to Earth in space terms. Like, obviously we're thousands of light years away, but we are close compared to how big space really is. Here is a purple gas giant. Wow. That's cool. Got a lot of bands on it. Are these little dots little storms? Yeah, they are. Look at those. They look like little holes going through the band, but they're actually little storms on it. And it's got one blue band. I wonder what causes that. There's got to be some form of gas that's causing that. Is this a planet too? Okay, there's a gas giant that's really, really close to the star that is completely being burned up. Wow. Look how close it is to the star. That's crazy. And then we got, what is this here? Another planet also being completely burned up. It's touching the corona of the... Look, you can see all of the solar like energy being released is literally hitting the planet. What's our temperature? Average temperature is 1800 Celsius. It's very, very, very hot. And you can see even the moons are glowing hot. Can we even select them? Yeah, we can. Okay, they're micro Terra. So like, look at these. They're just balls of lava. But the lava has texture too. It's not just smooth. Look, it's like mountains of lava. Like, could you imagine being this close to the star? There's no way you could live. The temperature right here is almost 3000 Celsius. That's crazy. The view of the star is very, very cool. You would need like the thickest sunglasses ever. And you need sunglasses for your whole body not to die. Some SPF 1 billion. To not die immediately. And you can see there's some colder areas and those are darker and almost have like a ground texture to them. It almost looks like they're cooling into rocks. But then once we get to the hotter areas, it's more lava. Wow. Okay. Okay, let's see what else is around here. So it looks like the first 3 planets in this system are all extremely close to the star. How big is the star? I think this means it's 3.4 times the size of the sun, which is very, very big. But in space terms, stars can get a lot bigger. Here is a gas giant. This is the furthest out gas giant in this system. It's kind of got a cool yellow and purple blue kind of thing going on. Rings similar to Saturn, except not quite as thick. Saturns are thicker. This is a big moon. Wow. This almost is planet size. It is. Oh, wow. This moon is... I'm pretty sure this means it's as big... It's bigger than Earth. Are those clouds? They are. This moon has clouds, guys. Let's go under the clouds and see what's in here. Okay, it's like a blanket. Look at that. It is just like you're out of the atmosphere and then you're in. And it's like... It's almost like that one planet in Interstellar where they have frozen clouds. It kind of looks like that. Except the ground is too flat. There's not enough... Are there any mountains? Let's see if we can find any. There are a little bit. Let's get over here. Here we go. We're getting some more rough terrain. This will look cooler. Like, check this out. You're just underneath this blanket of clouds. Oh, it's even got some other minerals, it looks like, besides just whatever that gray stuff was. Red, reddish, yellowish. Oh, it's even got pink. That looks like it's bugged out. It's got little bits of blue in it, but it's like pixely. Wow. So that's cool. That's a moon of the gas giant, and it's got clouds on it. These other ones kind of look cool. Pretty standard looking moon. What about this one? Does this have clouds too? I don't think those are clouds. I think it's just very white. And it's got very big crater type formations. Are these craters? Or are they just like... It's like almost like there's a mountain range surrounding it. That's what it is. There's mountains going all around except for in here. I wonder what causes that. Because these are... Why are they so bright? Is my thing adjusted right? Okay, that looks a little better. This planet is just so white. It's got blue in it too. I wonder what this blue comes from. What mineral gives it this almost light blue color? Is it ice? Is there any info about ice? Atmosphere composition is N2 and carbon dioxide. Huh. Wait. The rotational period, it takes 52,000 days to rotate? But it's not tidally locked? That's crazy. 52,000 days? Well, we need to be locked. To see this correctly, we need to be locked to the surface. That might be the highest I've ever seen. The rotational period is 1 to 1. Oh, does that mean... Oh, okay. Wait, I think this means that it's tidally locked, but not to the star, to the planet. Which would make sense. I was confused. Because usually if it is tidally locked, it'll tell you. But I think that just means it's locked to the planet. Which would be like our moon. Where the same side of our moon always faces us. Alright, that was a cool system. Let's go a little further out in the Milky Way. Before we leave the Milky Way, let's do one more system. Okay, so here is the Milky Way galaxy. Why is this star so far away? Oh, it's a star cluster. Okay, wait, this is kind of cool. This probably is real. Yeah, real object. So this cluster actually exists in real life. So let's see what's in here. If we can see any cool planets. A lot of these are binary systems or even 3-4 star systems because there's so many stars nearby that they all kind of combine together. Here's a black hole. Let's check this out. Whoa, black hole. Let's search for life here, actually. I'm going to do a life search. See if we can find an Earth-like planet in this cluster. Multicellular life. All right. None within 10 light years. Let's go the max, 400. Let's see. Interesting. No Earth-like planets within 400 light years of this black hole. Let's try a new spot in the cluster. Come on, speed up. Let's go up here in the cluster and try that search again. Let's do doesn't matter. So we'll just search for Earth-like planets, but they don't have to have life. Here we go. We're getting more. So these planets are all very similar to Earth, but not necessarily... They don't necessarily have life. So here's one that looks like Earth. No life on this one. But very cool ocean formations. It's got a decent amount of water. I think a little more coverage would be ideal for life. There's not a ton of clouds. But like, what is all this land filled with? Are these rivers? Okay, so there are some rivers. The ground, why it's yellow. Huh. I would not have expected it to be yellow from orbit, but it looks like it's got a very blue sky, similar to Earth, but almost thicker. Oh yeah, atmosphere pressure is 46 times our atmosphere. It's got a very thick atmosphere. It's not super hot though, so it's not like Earth or not like Venus. It says the sea composition is liquid CO2. You're telling me this isn't water, it's liquid CO2? That cold? There's no way. I don't know if that's real. Liquid CO2 covering it like this? I mean, it could be. I don't know. Let's see what other Earth-like planets came up. Let's see if we can find a cool one. Oh, there's life, but I don't think it's on the right planet. Okay, temperate marine megaterra. Megaterras are cool. They're very, very large Terra planets. Like, check this out. Oh, wow. So this almost, it's got very orange features like Mars, but it's got water. This looks just like Mars. Oh, and it's got the twin suns. This is like Tatooine. Tatooine here. And for some reason, this one also says liquid CO2 is the ocean. I don't know why it says that. Tell me this doesn't look just like a terraformed Mars. Are we tidally locked? I don't think so. Rotational period 9 hours. Let's see the other side of it. Got some small moons, it looks like, going around. Yeah, this looks like a terraformed Mars. That's cool. It's got great liquid coverage. Like, this is ideal, I think, for life to develop if it is water, because I don't know why it says liquid CO2. Interesting. Okay, let's go out of the Milky Way now. Go ahead and leave. So that was a cluster on the edge of the Milky Way. Let's go really far. I just want to go completely away from everything we've ever discovered and find completely randomly generated galaxies. So this is the maximum speed you can go, which is 100 million light years every second. And every dot we fly by are galaxies that we're flying by. Each one of those, like, imagine the entire Milky Way, and that's every single dot we're flying by. So every single dot has billions of stars in it. Okay, let's go to this one. This looks too similar to the Milky Way. I want one that looks kind of different. Like, these spiral ones are cool, but I want one that's almost irregular, maybe. Spiral. So I'm looking at, this one says type E6, which I'm actually not sure what that means. Oh, that's one of these, like, I want one that's irregular. This one's spiral also. That's kind of cool, though. S0, what's that? Also spiral. It's crazy how many different types of galaxies there are, and it looks like SpaceEngine simulates all of them. Whoa, okay, wait, this is actually kind of cool. This is a galaxy that is shaped like almost like a bullet, and it doesn't even have that many stars. This is a small galaxy. Oh, but once you get in here, check this out. Never mind, there's so many stars in here. Like, that's how crazy galaxies are. Like, it doesn't even look like that much from out here, and you fly in it. Look at all those stars. Okay, let's go towards the center. The star dense, it's so dense. No way, this has 3 planets with life and I just clicked on it. That is crazy. I've never clicked on a system that have 3 objects with life. The most I've ever done is 1. 3 objects with life in one system is crazy. So let's find them. This is Earth-like. I don't think I've ever found one of these on accident. I've always had to search. Multicellular marine and terrestrial life on a planet that I randomly clicked on. That's gotta be crazy. I've never done that. I don't think I've ever accidentally found Earth-like life. It does say marine, but I don't seem to see much water. There's a little bit here. Let's see what our stats are looking at on here. So the sea's composition, it does say H2O this time. So this is definitely water. Whoa, the sky is like super thick. What's our pressure? 213 atmospheres of pressure? What? How is life here? How is this more habitable than those other planets we were looking at? Because the ocean's not made of CO2. Oh, wow, though. Okay. Got 3 moons. Temperature's hot, very hot, 140 Celsius. Wow. I do not get how life could live here. Earth similarity index is at 71%. I mean, there are, even on Earth, there's life that can survive in the harshest of conditions. So, if you evolved to live in an environment like this, I'm sure you could thrive. Very cool to find that randomly clicking around. Also, they're in the same system. There are two other objects with life. I think they're both subglacial, which is the most common type of life. It's just kind of life that lives underneath, like inside of glaciers, inside the ice on these moons. Like microbacterial, you know, little tiny stuff that you would need a microscope to see. So not anything significant. But there's one there, and this one also has subglacial life. But in that same system, there's also Earth-like life, marine and terrestrial multicellular life on that planet. Randomly clicking around, that's really crazy. Well, this looks like Io, at least from the little picture. Let's see how it looks up close. That kind of does look like Io. I don't think it's as volcanic though. No, definitely not. But the atmosphere is kind of like this blue color. I want to see what a sunset's gonna look like on here actually. Oh, it looks more green when you get close. But there's the star. Let's watch a sunset though. Very blue sky actually. Like super light blue. There's the star. We're gonna watch it go down now. See what a sunset looks like. This will be cool. Okay, I'll slow it down. Here we go. Sunset on this random planet in a random galaxy. But that's it. It's the mountain. Oh, the mountain was blocking. We're not even close to sunset yet. False alarm. Give it a minute. Here we go. There it goes. What colors pop out? Let's see. White? Like, what? Nothing really. Just blue and then the yellow. Is that the yellow reflecting off the surface? I think it could be coming from the star, but that was very underwhelming actually. A little bit of green when the blue and the yellow kind of combine. And that's it. That's what we see. Look at the density actually of the stars. When you look at something bright, it's gonna ruin your exposure, but check this out. There's so many stars in this little galaxy, this bullet-shaped galaxy. I was not expecting that. It didn't look like it had that many from when we were outside of it, but we can actually, this is the default settings. You can turn up the star brightness. Like, check that out. I don't want to blind you guys, but check that out. The game's gonna get buggy because it has to load in more stars. All right, that's a cool galaxy. Let's see what other galaxies we can find out here. Flying through the universe, you can actually see like the structure, how they kind of align themselves. Like there are big pockets, like right here. Look at this big pocket that we're flying through right now, where there's just nothing. There's absolutely nothing in here, and it looks not that big, but it's millions, billions of light years across. Being in here, this is what you want to know. What you would really see in here? You would see this. This is what it would look like out here. You would nothing. You would see absolutely zero, and you wouldn't even be able to go anywhere. Like being out there would be, you would be the most alone you could ever be. It's kind of crazy. Like people talk about the voids, like the, what's it called? The Buddha's void. Those are so insane that there's these giant pockets where there's actually just nothing in the universe. Okay, let's see what kind of galaxies are out here. Another spiral one. Let's see if we can find like a weird looking one. No. It's S0. I'm looking at this type up here. Oh, weird. Oh, wait. Why does this one look like that? This almost looks like a nebula. But it's a galaxy. Okay, let's see the density Honestly, not too dense. Not nearly as much as that other one we saw. It's almost got like a cloudy kind of vibe to it. See if there's any cool planets just from clicking. A lot of blue. Oh, there's life. Unicellular marine life. So this might be the early stages of life developing on this planet, because there's only single-celled organisms in the oceans. So this is kind of early life, I would assume. Let's see. Is there any water even? What do you mean there's marine life? I don't even see any liquid. Where's the life living? Is it just like, are these rivers and it's just living in here? What? There's no way the life is just living in these rivers? That's crazy. I would think there would need to be big oceans for a lot of good life to develop. Like on Earth. But it could just be early stages of this planet. Maybe there'll be more liquid on it later. What else is around this planet? Oh wait, this kind of looks cool. Whoa, this is a very, very cool colored little gas giant. Sub Neptune, so it's the ice giant. Tidally locked with the star. This might be the... I don't think I've ever seen a gas giant in this color. It's like mint green. Does anybody know? If you do, let me know in the comments if what kind of like gases are gonna make it look this color, and if like this is realistic or if SpaceEngine is just putting random colors on the planets, because I'm actually not sure. We're kind of underneath it in the atmosphere. Whoa, wait, why is it kind of see-through? Why is there like a surface down here? What? Like a black surface. Interesting. Interesting. Oh, what's this moon? Like, could you imagine if we had a gas giant that looks like this? People would love it. That'd be everyone's favorite if Jupiter would look like this. Because I feel like we do have cool colored gas giants. This is almost like, it kind of looks like Uranus, but I think Uranus isn't that minty. Uranus mixed with Jupiter is kind of what that looks like. Yeah, kind of, but that planet was a lot brighter. So Uranus mixed with Jupiter is what that planet was sort of like, but it was even mintier than that. Okay, let's fly out of the solar system again, and let's kind of go over here. There's always like these random bright galaxies that catch my eye. Let's see what this one is. Okay, so this looks like not that much right now, but it's going to be similar to that bullet one. Watch, when we fly in, super dense. Like, look at all the different colored stars. You can just fly through it. Okay, here's a cluster. Let's see what we can find. Okay, wait, here's what we're going to do. I'm going to look right outside the cluster because I want a planet that... Where'd my cluster go? Is that a cluster? What? I lost it. What? No. Okay. Instead, we're going to look for a nebula because we haven't found any this video yet. So let's go camera and turn up nebulae. And you can definitely start to see them now. Let's go to... Oh, wait. There's like a mint one right here. Planetary nebula. Here we go. Oh, wow. Okay. Put them back at their normal brightness. Okay. So I'm going to go in the nebula, even though there's not that much in here, because I'm pretty sure planetary ones come from... It's a supernova, and that would be the remnant, like the core of the star, I think. And I'm going to search for an Earth-like planet right here, because I want to find one where during like night, we can look up into the sky and see that nebula. Okay, none there, but let's go. Let's just turn off the life part and then just find a Earth-like planet here. Okay, so here's gonna be the closest one. Wait, no way. Is this the same? No, we're not in the same galaxy. There's no way. But look at this gas giant that looks just like the other one we just saw. What? That's crazy. I thought for a second it was the same one, but that wouldn't make sense because we're not even in the same galaxy. What? Okay. Anyway, we're trying to look for the Earth-like planet. Here we go. Temperate marine Terra. This is going to be our most Earth-like planet. We have atmosphere and clouds turned off. Okay, so that nebula we were just in, where did that go? Let's just wait for night on this planet and see what we can see in the sky. So this is very deserty. Doesn't have life, but it is similar to Earth. It's got an ESI of 94, so it's actually 94% like Earth. But just subtle differences can make it not habitable, like 150 atmospheres of pressure. That's very high. Okay, we're waiting for night. These rings are actually going to make it kind of hard to see the night sky. People don't think about that when they think about rings. Let's see what we can see this way. I don't see that nebula. We might be too far from it. Let's turn the nebulae back up in the camera. And then I can start to zoom in on some. Like there's one there. We'll go realistic lighting. If you had a telescope on this planet, you could see stuff like this. Whoa, okay, wait, that actually looks kind of weird. Looks like a pill. That one there. What is that? Why can't... What? That's max zoom. It must be a star. These like little pink dots have got to be, right? Is that one? There. Okay, wait. Adjust. Okay, that red one there's got to be a nebula. Oh yeah, for sure. Oh wow. Okay, that must be game breaking. You can see the kind of like pattern on top of it. But there's no way it looks like that up close. If it does, that's got to be a game bug. Oh yeah, it doesn't. It was just the way we were zoomed in on it. There we go. Okay, that is going to be it. We're going to call it there. Thank you all for coming to this video. If you are still watching, then you're either asleep or you enjoyed it, so you should like it. If you want to see more, please let me know. I would love to keep making these for you guys. Like the video. Thanks for coming, and I'll see you guys in the next video.